So the multiplication properties of real numbers are very similar to the addition properties of real numbers, with a couple notable exceptions. So let's look at them real quick. There's the commutative property. Of multiplication. And it says exactly the same thing the commutative property of addition says. It says that if you take a number and you multiply it to another number, that you're going to get the same result as if you took the second number and multiplied it to the first number. So it doesn't really matter which direction you multiply in. And an example of that would be 2 times negative 3. According to the property, that would be the same thing as negative 3 times 2. So let's see, 2 times negative 3 is negative 6, and on the other side, negative 3 times 2 is negative 6, and the property holds. The associative property, that's the one I did a long drawn out kind of description of. And it says, well, let me write it first. It says that if you multiply 3 numbers together, it doesn't matter whether you multiply the first 2 and then multiply the third, or whether you multiply the second 2 and then back to the first. It doesn't really matter which way you work. And so an example of that would be 2 times negative 3 times 4 equals 2 times negative 3 times 4. So you can see that I have associated them differently. Who each person is sitting with doesn't really matter as long as all the people are there. So let's finish this one up. 2 times negative 3 is negative 6 times 4. Does that equal 2 times, well, negative 3 times 4 is negative 12. Negative 6 times 4 is negative 24. And 2 times negative 12 is negative 24. So the path may be different that you get there by, but you're going to end up in exactly the same place. The identity property for multiplication works too. But remember, with addition, you're asking what can you add to a number to get the exact same number back out. So with multiplication, the identity element is different. With multiplication, the identity, we're asking what can I multiply a number by so that I get the exact same number back out, the identity. Well, that would of course be 1, and in this case we call 1 the identity element. Under multiplication. All right, so the identity property says that if I multiply 3 times 1, I get 3 back, the identity. 3 is 3, its identity is 3, I get 3 back. So under addition, the last property was the inverse property, but that doesn't actually work exactly the same way in multiplication. So we actually have 2 replacement properties with their own name for multiplication. One of them is the property of 0, which I don't actually like. I just call it the 0 property. And the 0 property says that if I take a number and multiply it by 0, I get 0. Basically, the 0 property says that under multiplication, 0 will eliminate or nullify a number entirely. And then, of course, the unnecessary, but I'll give it anyway, example would be negative 2 times 0 equals 0. And then the other property that replaces the inverse is the property of negative 1, or the negative 1 property. And you can imagine what that is, that A times negative 1 equals negative A, that you get the opposite. So multiplying any number by by -1 will give you the opposite of that number. And again, totally unnecessary, but we'll do it anyway. Let's say 6. Well, let's do a negative number. -6 times -1 equals +6. +6 is the opposite of -6. Done. And so there's it's not really a property, but there is multiplying positive and negatives together. So under multiplication, the behavior of positive and negative numbers, what is it? And basically it's that if you take a negative number and you multiply it to a negative number, you're going to get a positive number back out. And this is the sign of a product rule. It's not really a property, but it's a rule. And the example for that would be -2 times -3. 2 negatives makes a positive, and 2 times 3 is 6. So that would be the double negative rule. The double positive rule obviously works exactly the same. 2 positive numbers multiplied together, clearly going to give you a positive. So 2 times 3, both positive numbers, equals 6. 2 positives gives you a positive, 2 negatives gives you a negative. And then the last rule, or the last rule would be a negative times a positive, and that's always going to equal a negative. So in this case, -2 times +3 equals -6. A negative and a positive makes a negative. And the opposite also works. A positive times a negative also equals a negative, because we have the commutative property of multiplication, so that has to be true. So a few examples just to drive the point home. Multiply -8 times -6. 2 negatives makes a positive, and so 8 times 6 is 48. Example 2, a -2 times a positive 3.5 times a -4. The answer is going to be positive because 2 negatives makes a positive, and it'd be 3.5 times 8, and that would be the commutative property. I didn't want to multiply 2 times 3.5 and then multiply that by 4, so I took my integers, I just switched these two around. That's the commutative property. Did my -2 times -4 to get a positive 8, and now if I do the arithmetic, I get 28. All right, so example 3. Let's do a fraction this time. 1/4 times -12 times 3. So again, I'd really rather work with my integers first. My final answer is going to be negative, and so I'm going to multiply 12 times 3. Well, actually, in this case, because 12 and 4 share factors, in fact, they share a 4 as a factor, so I can reduce it. I'm going to multiply my first two together. 12 divided by 4, I've already decided about the negative, so I'm not going to worry about this one. 12 divided by 4 is 3 times 3, and so a negative and a positive is a negative, and 3 times 3 is 9. So all of these rules and properties hold true when we're dealing with variables. So if I want -2 times c times, and I don't really need these dots, I'm just using them to drive the point home that it's multiplication, because we're talking about the multiplication property. There we go, times 0.5. Well, I can do a bunch of things with this. One, I could go ahead and multiply -0.5 times c and just get -0.5 times c. Or I could rearrange it, because this is really -2 times c times -0.5, right? Then I can use the commutative property and switch these two around, so I get -2 times -0.5 times c. Then 2 negatives makes a positive, so I can just forget about those altogether and take 2 times 0.5 times c. And then 2 times 0.5 is the same as 2 divided by 2, or 2 divided in half, so I have 1 times C, so the answer then would be C. And I should stress, as you start to work on practice sets for this unit, that while you could probably do most, if not all of this math, this arithmetic in your head, while you're learning it, it's important that you report your process. So you can see that a simple problem can certainly be written out following a series of steps, and I had descriptions for each step. For example, the first step, I used the commutative property. Right? The second step, I used the negative rule. In the third step, I used the associative property because I decided to multiply these two first. And then the last step was just the solution. So you should, as you're working on this, you should consider the fact that I'm going to want to see that you can apply these various properties as you work through. Just because you can get simple problems in your head doesn't mean you're learning the concept, and I need you to show me the concept.